Hello to everyone watching this video out there. I'm Anik, the technical project lead of IEEE student branch GITAM. Hope you guys are doing great amid COVID-19 and all of you are growing hair just like me. Today I'm going to give you a briefing about facial detection, how it works, what goes on in the background, and how to make your own facial recognition software. So, are you ready to do some cool stuff? Let's start. In this time and age, facial recognition is very common. We are using this while unlocking our phones to keeping our homes secure. Guess what? All those funky Insta and Snapchat filters that we use, all of those are made up of the same concept. This is going to be so big that the Chinese government is going to use this to track their people's daily routine. The extent of this that will be used in the future is boundless. Hope you guys are excited to know how to make one of these. So let's dive right into the code. Okay, so as you guys can see here, this is the code of the facial detection software that I have made using Python. It's pretty much available everywhere in internet. If you want, you can get a copy in the description as well. I'll link that code in the description. This entire code works on two packages. Now, what packages mean? Packages are actually modules that are created by Python people who work in the community so that other people can just simply import those packages and run any kind of code using them, using the facilities that they provide. Now we have used two packages, CV2 and Numpy. Let's go brief them out what CV2 is and Numpy is. There are two packages that are used to make this software that are OpenCV and Numpy. OpenCV. The word OpenCV derives from the fact that the package is open source. It's available in the internet for free. And CV abbreviates to computer vision. Now you might ask, what is this used for? In simple language, OpenCV is used for image processing. There are a wide range of applications that this package can be used for, which simply starts from video capturing. We'll be using this application of video capturing while making of our software. Then the second package is Numpy. Numpy as a package is generally used for scientific calculations because of its ease to handle huge chunks of data in its arrays. It is one of the most commonly used Python packages by far. There are many ways to detect faces using OpenCV, but for our purposes today, I'm choosing the easiest and the most commonly used way to do it. We'll be doing it using HAR cascades. What are HAR cascades, you may ask? These are basically classifiers that are used to detect objects from the source. Now, how do these work? These are a set of negative and positive images. The negative images are the images that do not have the objects that you want to detect, and the positive images are the ones that have the objects that you want to detect. Confused, right? I've been there. No worries. You must be thinking, wait, what are these negative, positive images? I didn't get any of them. Don't be confused. Let me explain. If you want to detect humans, then here are the negative images. The negative images would be of anything other than human beings, like buildings, factories, anything, literally anything other than humans. And positive images would be obviously of the human beings. After we provide these databases to our computer, the computer processes these using neural networks that superimposes both the set of positive and negative images together and gives us a result that would only detect human beings. Now, the HAR cascades of different parts of human beings and expressions are available for free on GitHub. I'll be linking those in the description below, so if you need, you can go ahead and have a look. For our purposes today, we'll be specifically using the HAR cascade of frontal face. Now that we have discussed about the packages, let's jump right back into the code. Here we have imported the OpenCV and the Numpy libraries. Now we have to specify the classifier that we will be using. That is the har cascade classifier. With that, we also have to mention the location where it is there so that the system can refer to it while processing the images. Next, we use the OpenCV to extract the video using video capture function. We can see in this code that we are actually extracting images. Why? Because videos are nothing but a collection of images, and when these images are run back to back, you see a video coming up. We are also converting the images into grayscale because grayscale is a combination of two colors, black and white, and which is lesser than the colorful images, which are a combination of red, green, and blue. We do it to make the processing speed faster. Then using the rectangle function, we construct a rectangle surrounding the face that has been detected, and using the putText function, we put a string, some kind of a text above the rectangle constructed, just to make it cool. The IEEE function shows the output, and the wait key function is used here to break the video that's been captured using the webcam. Just once you press small q. Now the fun part. Let's run the code and see what's the output. There you go. You can see my face. Hi. And you can see the text that I've mentioned up there. It's been shown above the rectangle, and there's a rectangle that's been constructed around my face. That's been it. Doesn't this? Don't these glasses actually look cool, man? They look cool. Yeah. It was a pleasure briefing the process to you guys. If you guys have any doubt, be it silly or complicated, do mention that in the comment section below. So stay home, stay safe. See you guys until next time.